Hello everyone. In this video, we are going to discuss limitations of octet rule. We have already discussed octet rule. We have also seen some of its applications. We can explain the structure of most of the ionic compounds and some covalent compounds as well. Based on that, we were also able to calculate the formal charge on the atoms of polyatomic molecules as well as ions. In spite of all these uses, octet rule is not universal because it has some limitations. But before we go into the details, I am Anandavalli. I welcome you all to this new video from Guidance Education channel. Limitation number 1. Incomplete octet of the central atom. Even after formation of the molecule and the bond, octet is not completed in the central atom of certain molecules. First example, lithium chloride, LiCl. Lithium belongs to first group. So actually, it should form like other metals, ionic compounds. But lithium is an exception to first group. It forms covalent bond. Atomic number of lithium is 3. So the outermost shell, that is the valence shell, has only 1 electron. Lithium is the central atom in lithium chloride because lithium is less electronegative than chlorine. That is the criteria for deciding the central atom. Now, when you come to chlorine atom, lithium shares this 1 electron with 1 electron of chlorine atom and forms a single bond. The other 6 electrons of chlorine remain as 3 lone pairs. There are 3 sets of lone pairs. Now, the molecule can be represented as lithium, single bond, chlorine with 3 lone pairs for chlorine. Now, after the bond formation, how many electrons are there in lithium? There are only 2 electrons. 1 electron of lithium and the other electron of chlorine. So, the octet is not completed. It is a case of incomplete octet. Example number 2, beryllium hydride, BeH2. The central atom is beryllium because its electronegativity is less than that of hydrogen. Its atomic number is 4 and it has 2 electrons in its outermost shell. It is shared with 1 electron each of the 2 hydrogen atoms. So here you can note that there are only 4 electrons in the outermost shell of beryllium. So the octet is not satisfied. The molecule can be represented as hydrogen, single bond, beryllium, single bond, hydrogen. Now the third example, boron trichloride, BCl3. Boron is the central atom. It is less electronegative than chlorine. It has 3 electrons in its outermost shell, which is shared with 1 electron each of the 3 chlorine atoms. The remaining 6 electrons in each chlorine atom will form 3 lone pairs for each chlorine atom. The valence shell of each chlorine atom overlap valence shell of boron atom, which is the central atom. There are only 6 electrons there. Octet is not completed. Now let us draw the electron dot diagram for boron trichloride. I hope it is clear. There are other examples as well. I will mention 2 more. One is boron trifluoride. Another one is aluminium trichloride. In these compounds also, the central atom does not satisfy octet condition. You can verify these molecules yourself. Is that okay? What is the meaning of odd electron? That is, after formation of the bond, the remaining electrons, that is the electrons which do not take part in bond formation, should remain in the concerned atom as pairs. If any electron does not form a pair, that single electron is called odd electron. We will see certain examples in this case also in order to understand. First one, nitric oxide, NO. Nitrogen atom will be the central atom because it is less electronegative than oxygen. Then you have one oxygen atom. Nitrogen has 5 electrons in its outermost shell. 2 of those electrons share with 2 electrons of oxygen. So nitrogen forms one double bond with oxygen. Oxygen has 6 electrons in its outermost shell. Nitrogen has 3 electrons more. 2 electrons form one lone pair and 1 electron remains singly. That single electron is what we call odd electron. Now for the oxygen atom, 4 electrons remain. They remain as 2 lone pairs. Now their valence shells overlap. See, when the bond formation is over, nitrogen has formed a double bond with oxygen. It has 1 lone pair and 1 odd electron. The molecule can be represented as nitrogen double bond oxygen. Oxygen has 2 lone pairs. Nitrogen has 1 lone pair and 1 odd electron. I have repeated these points over and over again so that you understand what we mean by odd electron. Now the second example, nitrogen dioxide. Here also nitrogen is the central atom and there is 1 nitrogen atom and 2 oxygen atoms. Nitrogen has 5 electrons in its outermost shell. 2 of those electrons share with 2 electrons of oxygen. For convenience of explanation, let us number them as oxygen atom number 1 and oxygen atom number 2. Nitrogen atom uses 2 of its electrons again to form a single bond with oxygen atom number 2. That means oxygen atom number 2 is not contributing any electron to forming this single bond. Now oxygen atom number 1 has 2 lone pairs and oxygen atom number 2 has 3 lone pairs. None of its electrons are used for formation of this bond. The remaining 1 electron of nitrogen remains singly. That is the odd electron of the central nitrogen atom. Now let me show the overlapping of the various atoms in the compound. Now representation of the molecule. Nitrogen double bond oxygen with the first oxygen atom and single bond with oxygen atom number 2. 1 odd electron for nitrogen and nitrogen carries 1 positive charge. 3 lone pairs of electrons for oxygen atom number 2 with a negative charge. Oxygen atom number 1 has 2 lone pairs. It does not carry any charge. Using the formula you have already learned, you can verify the charge on these atoms. Now let us pass on to third limitation. Limitation number 3, expanded octet. As the name suggests, there are more than 8 electrons in the valence shell of the atom. Example number 1, phosphorus pentafluoride. There is 1 phosphorus atom and 5 fluorine atoms. Phosphorus is less electronegative than fluorine. Therefore, it is the central atom. Phosphorus has 5 electrons in its outermost shell and these 5 electrons are shared with 5 separate fluorine atoms forming single bonds. Each fluorine atom, like chlorine atom, both of them belong to the same group, has 3 lone pairs. Each bond corresponds to 2 electrons. There are a total of 5 bonds for the phosphorus atom. So, phosphorus atom has 10 electrons in its outermost shell. It is a case of expanded octet. Example number 2, hexafluoride of sulfur. There is 1 sulfur atom which is the central one and 6 fluorine atoms. Sulfur has 6 electrons in its valence shell and each electron is shared with 6 different fluorine atoms forming single bonds. Each bond has 2 electrons, 1 electron of fluorine and 1 electron of sulfur. So the central sulfur atom has 12 electrons in its valence shell. It is also a case of expanded octet. Each fluorine atom will have 3 lone pairs. I have not shown it here. Now, example number 3. Sulfuric acid, H2SO4. Sulfur is the central atom as it has the least electronegativity. It forms 2 double bonds with 1 oxygen atom each and 2 single bonds with the 2 other oxygen atoms. The 2 oxygen atoms with single bond now bonds also with 1 hydrogen atom each. All the 4 oxygen atoms have 2 lone pairs each. From the diagram, you can easily understand that sulfur atom has 12 electrons in its valence shell. So this also is a case of expanded octet. Now we will proceed to see some other drawbacks of octet rule. Drawback number 1. Octet rule is based on the fact that noble gases have octet structure in their valence shell and they are inert. That is, they are stable. They have a stable octet structure. But in reality, all noble gases are not inert. That is, they are also reactive. Some of them form compounds. They undergo reaction to form compounds, of course, under certain drastic conditions. Yet, they form compounds. For example, xenon forms xenon fluoride. Similarly, krypton fluoride. Another compound of xenon is oxyfluoride of xenon. So the concept that elements undergo chemical reaction to attain stable octet electronic configuration in the outermost shell itself is questioned here. Second drawback, octet rule does not give the shape of the molecule. It does not explain the reason for the shape of the molecule. Drawback number 3, it does not explain the relative stability of molecules. It also does not explain the energy of molecules. So in all, we have discussed 3 limitations and 3 drawbacks. If you think the video is useful, do like the video, share the video with your friends who may also be benefited, and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do support me by subscribing my channel. Press the bell button and all button for notification of more videos like this. Thank you very much. We will meet in the next video with another important topic. Till then, bye. Take care.